Welcome back, viewers, to the Stellar Twin Voyagers program. Today, I, Nova A239, will once again guide you through another adventure of the siblings striving to explore their colorful dreams. Let's together explore the eternity of a million ages and fill our dreams amidst the sea of stars. Get ready to be enchanted by the wonders of the universe and stories full of hope that will inspire us all. The morning has dawned again brightly. A new page has begun. The two siblings resume their activities, tending to their sheep as usual. Bro, the shooting stars last night were so beautiful, weren't they? I really look forward to the Geminids meteor shower in December, said Cosmo. You're right, but December will be really cold. We might need thicker clothes by then, because last night was quite chilly already, replied Aster. Cosmo nodded in agreement. But don't worry, the Perseids meteor shower hasn't completely passed yet, right? And there are still many meteor showers we can observe before December, right? Like the Draconids, Orionids, Taurids, Leonids, yeah, those are pretty good. Of course, that also means we need to help Dad and Grandpa more because we'll soon be entering winter and there's a lot we need to prepare for. Anyway, let's hurry to fetch water and get back home, said Aster. Cosmo nodded and immediately assisted his older brother. After everything was done, they hurried back home. Along the way, Cosmo stopped for a moment and pointed to the eastern horizon. Look, bro, is that Venus? And which star is that? Cosmo asked, pointing to the eastern sky. Yes, that's Venus, Cosmo. The other one isn't a star, Cosmo, it looks more like, oh yes, Jupiter, it's Jupiter, explained Aster. Let's ask Grandpa more about planets later, okay, bro, Cosmo said as they continued walking. Sure, but we'll have to wait until Grandpa finishes resting. You, always, even though you've been told countless times, still bother Grandpa when he's just about to rest, Aster teased. Hee, Cosmo chuckled, scratching his head. Let's walk faster now, Mom must be waiting at home, said Aster. Okay, brother, Cosmo replied. Mom, we're back. Grandpa, Dad, good morning, Grandpa, good morning, Dad. We were just thinking of calling Dad and Grandpa from the field after we returned from fetching water, Aster said as he entered with a bucket of water. Dad smiled and immediately got up to help carry the buckets lifted by his two sons. Come here, Dad will help carry them to the back. Right, today Dad will go to town to sell the corn we just harvested, so Dad will only go to the field briefly to check things out, and then hurry back. Since Dad won't be around later, you two need to help Grandpa more, understand? Understood, Dad, the two boys replied. Good, let's quickly wash your hands and feet, and get ready to join us at the dining table, said Dad. Okay, Dad, Aster and Cosmo said, then rushed to the backyard to clean themselves and quickly returned to the dining table. Mom had already prepared dinner, and they immediately enjoyed their breakfast. Wow, breakfast today is really delicious. Mom's cooking is the best, Cosmo said happily with his empty plate. That's right, your mother is indeed the best at cooking, Dad agreed, quickly getting up to clean his teeth and face. Is Dad leaving already? Asked their adorable sons. Yes, Dad is about to leave. Dad has also put the sacks of corn in the cart. Of course, the sooner Dad arrives at the market, the more corn will be sold. My wife, I'm leaving now. Aster, Cosmo, take care and help Grandpa. Be Dad's pride, Dad said, then quickly climbed onto the ox cart. Okay, Dad, be careful on the road, said their two sons, waving goodbye to their father. Grandpa, Mom, we're going to herd our sheep first, said Aster and Cosmo. All right, don't come home too late, Mom called from the kitchen. Okay, Mom, Aster and Cosmo said, then ran to their sheep pen. Slowly, they led their sheep to graze and watched over their flock. It's getting colder, isn't it, bro? Cosmo said, feeling a bit chilly. True, autumn seems to have arrived earlier this time. We should ask Grandpa about preparing hay for winter. Let's finish our tasks and then meet Grandpa, Aster suggested. Okay, bro, Cosmo agreed. They divided the tasks to watch over the flock of sheep, and after all their sheep had eaten their fill, they led them back to their pen. Yosh, our first task is done. Now let's quickly meet Grandpa in the field, Aster said. Cosmo nodded. They ran towards the field and found Grandpa tidying up their cornfield that had just been harvested. Grandpa was seen cutting the remaining corn stalks and throwing them to the ground. What are these for, Grandpa? All these stalks? Cosmo asked innocently. We're going to make straw. To prepare feed for our sheep in winter. The parts that can't be used for feed will be left here to nourish the soil. Let's get to work, Grandpa explained. All right, Grandpa, the two grandchildren said. With enthusiasm, they all worked together and finally managed to finish 4 plots of the field after about 3 hours of work. Grandpa then walked towards the pile of stalks and started sorting them. What's up, Grandpa? Aster asked curiously. We're going to sort these stalks and take the fiber-rich parts that can be used as animal feed. The parts that are too tough and hard to digest will be discarded. Let's help Grandpa with this, Grandpa said. The two grandchildren nodded and began to assist their grandpa. Finally, all the stalks were sorted out well, and Grandpa walked to the edge of the field and brought a sack. What's that, Grandpa? Cosmo asked. This is, Grandpa said, then emptied the sack and spread its contents together with other stalks that had already been flattened on the ground earlier. Ah, don't tell me, husks and silks, from the corn we helped Dad clean, Aster said. That's right, we'll also dry these to make straw. This part is rich in fiber and suitable for animal consumption, Grandpa explained. Oh, I see, Grandpa. There's so much I didn't know, Aster said. All right, this should be enough. Now let's let it all dry completely into straw so we can bale it into straw boxes, Grandpa said. Okay, Grandpa, Aster and Cosmo replied. Now it's time for us to rest. Aster, Cosmo, did you bring packed lunch? Grandpa asked. Oh, no, Grandpa, we haven't. We'll go back home now and bring lunch, then come back to the field, Aster said. Without further ado, they ran back home and returned to the field with packed lunches. Grandpa, we're back, said Aster waving his hand. All right, come here, let's enjoy our lunch, said Grandpa. Then they opened their lunch boxes and happily ate. After they finished eating, Aster and Cosmo let Grandpa rest for a while. With his eyes closed and fanning himself with a caping, Grandpa asked, all right, after watching the meteor shower show last night, do you have any other questions or do you want to ask about other topics? Grandpa will open a Q&A session today. Please, my adorable grandchildren. Yes, Grandpa, I have a question, said Aster raising his hand. Yes, what's your question? Asked Grandpa. Grandpa, this morning when we were on our way back to fetch water, we saw Venus in another bright spot. I told Cosmo it was Jupiter, is that correct, Grandpa? Asked Aster. Yes, that's right, said Grandpa, that was Jupiter in western elongation. Since you happened to ask about planets, and also yesterday night Grandpa promised to explain about asteroids, the Kuiper Belt, and so on another day, Grandpa thinks today is the right opportunity to explain it. Do you want to hear about it? Certainly, Grandpa, we want to hear about it. Tell us, Grandpa, said both grandchildren enthusiastically. Good. All right, Grandpa will explain it to you. So, our own Earth along with many other planets is just part of the solar system. The solar system itself is a planetary system consisting of the sun at its center and various objects orbiting it, including planets, natural satellites, asteroids, comets, and interplanetary dust. Our solar system formed about 4.6 billion years ago from a collapsing cloud of gas and dust under its own gravity, resulting in a protoplanetary disk where planets and other objects formed. Our solar system consists of various different components. The sun, yes, the sun shining up there, is the star at the center of the solar system, contributing about 99.86% of the total mass of the system. The sun is the primary source of energy for all objects in the solar system. Then there are 8 major planets orbiting the sun. The word, planet, comes from the Greek word, planet meaning, wanderer, or, wandering star, because planets appear to wander across the sky against the backdrop of fixed stars. There are 2 categories of planets based on their location and characteristics: inner terrestrial planets like Mercury, Venus, Earth, and Mars, which have rocky surfaces and are smaller compared to the outer planets, and outer Jovian planets like Jupiter, Saturn, Uranus, and Neptune, which are gas or ice giants much larger and with thick atmospheres. Many of the planets in the solar system have objects orbiting them, called natural satellites, moons like the moon orbiting Earth or Europa orbiting Jupiter. Then there are dwarf planets, like Pluto, Eris, Haumea, Makemake, and Ceres, which do not meet all the criteria to be classified as major planets. Asteroids, which are small rocky bodies mostly found in the main asteroid belt between Mars and Jupiter. Comets, which are objects mostly made of ice and dust, with highly elliptical orbits, and as they approach the sun, they develop a visible coma and tail. The main asteroid belt located between Mars and Jupiter contains millions of asteroids. The Kuiper belt located beyond Neptune's orbit contains icy objects and dwarf planets. The Oort cloud, which is a theoretical region far beyond the Kuiper belt, believed to be the source of long-period comets. Also, interplanetary dust and small particles scattered throughout the solar system, often originating from asteroid collisions or comet activity. Each of these components Grandpa will explain more deeply another day. Today, we'll focus first on discussing the inner planets. Okay, as Grandpa mentioned earlier, there are several planets with Earth-like characteristics called inner planets. The inner planets in the solar system are Mercury, Venus, Earth, and Mars. They are known as terrestrial planets because of their rocky surfaces. First, Mercury. Its dark gray color is due to a surface full of silicate rocks and little oxidized iron. Its diameter is about 0.38 times that of Earth. Its mass is about 0.055 times that of Earth. Its density is about 0.98 times that of Earth. The rocks that make up Mercury are formed from silicates, mainly plagioclase, pyroxene, and olivine, and iron. Its core is believed to be large and partly liquid, mainly consisting of iron and nickel. Mercury's atmosphere is very thin, and its exosphere consists of hydrogen, helium, oxygen, sodium, calcium, and potassium. Its temperature can reach 430 degrees Celsius during the day, but at night it can drop to minus 180 degrees Celsius. Mercury rotates very slowly, 59 Earth days. However, its revolution is fast, about 88 Earth days. Due to a 3-2 rotation revolution resonance, 1 solar day on Mercury, 2 rotations lasts about 176 Earth days. Unfortunately, Mercury does not have a natural satellite. Second, Venus. Its golden yellow color comes from a thick layer of clouds containing sulfuric acid and sunlight reflection. Its diameter is about 0.95 times that of Earth, and its mass is about 0.815 times that of Earth. Its density is about 0.95 times that of Earth. The rocks that make up Venus consist of silicates such as basalt and granite and iron. While its core is believed to consist of iron and nickel, partly solid and partly liquid. Venus's atmosphere is very thick and dense, consisting mainly of carbon dioxide 96.5%, nitrogen 3.5%, and traces of other gases. Its pressure is quite high, about 92 times Earth's atmospheric pressure, in stark contrast to Mercury, which has almost no pressure. The average surface temperature is 465 degrees Celsius, nearly constant between day and night. Venus rotates very slowly and its rotation is retrograde, 243 Earth days. Meanwhile, its revolution is 225 Earth days. Therefore, a day on Venus is longer than a year on Venus, and its rotation is opposite to its orbit. Like Mercury, Venus also does not have a natural satellite, Grandpa explained, then paused briefly to take a drink. Alright, Grandpa will continue. Third, our beloved Earth. Surely you already know, the color of Earth is whitish blue with green and brown hues. The blue comes from the oceans, white from the clouds, and green and brown from the land. Earth's diameter is 12,742 kilometers. Its mass is about 5.97 times 10 to the 24 kilogram. Its density is about 5.513 grams per centimeter cubed. The rocks that make up Earth are silicates such as basalt and granite and various minerals. Its core is made of iron and nickel, with a solid inner core and a liquid outer core. Earth's atmosphere is a mix of gases, consisting of nitrogen 78%, oxygen 21%, and other gases such as argon and carbon dioxide. Its pressure is 1 bar at sea level. The surface temperature varies, averaging around 15 degrees Celsius, with extreme variations from about minus 89 degrees Celsius to 58 degrees Celsius. Earth rotates in 24 hours, which we call 1 day. Its revolution is about 365.25 days, which we call 1 year. Earth has an axial tilt of 23.5 degrees, which causes the four seasons in the northern and southern hemispheres. The Moon is Earth's only natural satellite, with a diameter of about 3,474 kilometers. Fourth, Mars. Its red color is due to iron oxide rust covering its surface. Mars' diameter is about 0.53 times that of Earth, while its mass is about 0.107 times that of Earth. Its density is about 0.71 times that of Earth. The rocks that make up Mars are mainly basalt and andesite, with a high iron content. Mars' core is believed to consist of iron, nickel, and sulfur, possibly partly liquid. Mars' atmosphere is very thin, consisting mainly of carbon dioxide 95.3%, nitrogen 2.7%, argon 1.6%, and traces of other gases. Its pressure is about 0.6% of Earth's atmospheric pressure. During the day, the temperature on Mars reaches about 20 degrees Celsius at the equator, while at night, it can drop to about -153 degrees Celsius. Mars rotates about every 24.6 hours, while its revolution takes about 687 Earth days. Mars has two small satellites, Phobos and Deimos, which are believed to be trapped asteroids. Phobos' diameter is about 22 kilometers, while Deimos' diameter is about 12 kilometers. Yes, that's about the inner planets. Now, Grandpa wants to continue explaining a bit about the main asteroid belt, Kuiper belt, and Oort cloud, although actually Grandpa should explain the Kuiper belt and Oort cloud after explaining the outer planets. Do you want to hear about it? Grandpa asked. Yes, Grandpa, we want to hear, said the grandchildren excitedly. All right, but for today, let's stop here. We'll continue with the outer planets and other objects another day. First, the main asteroid belt. This is a large collection of asteroids orbiting the Sun, located between the orbits of Mars and Jupiter. This belt contains millions of asteroids, which are remnants of the early solar system formation that never coalesced into planets. This belt contains millions of asteroids, which are remnants of the early solar system formation that never coalesced into planets. The asteroids in this belt vary in size, ranging from dust particles to large objects with diameters of hundreds of kilometers. Some of the well-known objects in the main asteroid belt include Ceres, the largest dwarf planet in the asteroid belt, with a diameter of about 940 kilometers. Ceres is the only asteroid in the belt large enough to be almost spherical due to hydrostatic equilibrium. Then there's Vesta, the second largest asteroid, with a diameter of about 525 kilometers. Vesta has a diverse surface with large craters and very high mountains. Another example is Pallas, the third largest asteroid, with a diameter of about 512 kilometers, and it has a somewhat tilted orbit. The last example is Hygiea, the fourth largest asteroid, with a diameter of about 430 kilometers, known for its nearly spherical shape. There's something unique happening in this region. The strong gravity from Jupiter affects the distribution and orbits of asteroids in this belt, creating Kirkwood gaps, which are regions with few or no asteroids due to orbital resonances with Jupiter. Next, Grandpa will explain about the Trojan asteroids. Trojan asteroids are a group of asteroids that share an orbit with large planets, especially Jupiter, but they're also found in the orbits of other planets like Neptune and Mars. They are located in the Lagrange points L4 and L5, which are two stable gravitational points in front of and behind a planet as it orbits the Sun. Lagrange point L4 is 60 degrees ahead of the planet while L5 is 60 degrees behind it, from the planet they follow. The sizes of these asteroids vary from several kilometers to over 100 kilometers. The composition of these asteroids is similar to those in the main belt, consisting of silicate rocks, carbon, and ice. There are some famous examples of objects that are included in the Trojan asteroids such as Hector, one of the largest Jupiter's Trojan, with a diameter of about 225 kilometers and has an elongated shape. Also Patroclus, another large Trojan with a diameter of about 140 kilometers, famous for being part of a binary system with the asteroid Menoetius. Trojan asteroids remain stable in their orbits due to gravitational resonances with large planets, especially Jupiter. However, they are difficult to observe from Earth because their position is close to the line of sight to the Sun. Now, let Grandpa explain about the Kuiper belt. The Kuiper belt is a region in the solar system that begins from Neptune's orbit 30 astronomical units and stretches to about 50 astronomical units from the Sun. This region is filled with small icy objects known as Kuiper belt objects KBOs, including dwarf planets. The sizes of KBOs vary from several kilometers to thousands of kilometers. Their composition consists of ice, water, methane, ammonia, and rocks. Some well-known objects here include Pluto, yes, the object that was once considered a planet, which is now a famous dwarf planet, with a diameter of about 2,377 kilometers, which was originally classified as the ninth planet before redefined as a dwarf planet. Then there's also Eris, a slightly larger dwarf planet than Pluto, with a diameter of about 2,326 kilometers and has a highly elliptical orbit. Haumea, a dwarf planet with a highly elongated ellipsoid shape, has a diameter of about 1,960 kilometers. And Makemake, a dwarf planet with a diameter of about 1,430 kilometers, one of the largest objects in the Kuiper belt. The Kuiper belt itself is home to many trans-Neptunian objects, including dwarf planets and candidate dwarf planets. KBOs are often considered as remnants from the early formation of the solar system, believed to provide insights into the early conditions of the solar system. The last one for today, Oort cloud. But wait, let Grandpa drink some water first, said Grandpa, then drank a glass of water and took a breath before continuing. Alright, the Oort cloud is a large spherical cloud surrounding the solar system at a very distant range, estimated between 2,000 to 100,000 astronomical units from the Sun. It is home to long-period comets influenced by gravitational disturbances from other stars in the giant molecular cloud. The Oort cloud is an extensive region with many comets. They consist of ice, water, ammonia, methane, and dust. Some famous objects from the Oort cloud include C. 1995-01, also known as Hale-Bopp, a famous long-period comet that was clearly visible in 1997. Then there's 1I Oumuamua, the first interstellar object detected entering the solar system, exhibiting characteristics similar to comets. The Oort cloud serves as a reservoir for long-period comets, considered to originate from gravitational interactions with other stars. Although its existence is supported by indirect evidence, there have been no direct observations of objects in the Oort cloud due to its immense distance. When explaining earlier, Grandpa used the O measurement. 1 astronomical unit is about 150 followed by 90 meters in length. A very large scale indeed, isn't it? Explained Grandpa. Well, yes, Grandpa. It seems our solar system is incredibly vast, Aster said in amazement. Exactly right. For us living on Earth, this is already incredibly far and vast. But, our solar system itself is just like a grain of sand in the vastness of this infinite universe. Alright, I think that's enough for today. We'll continue another time. I need to get back to work, said Grandpa. Okay, Grandpa, thank you for today's story. We'll tidy up the lunch boxes and we'll soon help you in the fields, said Aster and Cosmo. Grandpa smiled proudly at his grandchildren and walked towards the fields. And that concludes today's episode of the Stellar Twin Voyagers. Fun, isn't it? Would you also like to explore the awe-inspiring space up there? Therefore, stay with us on this program, and we will meet again in the next episode. In short, I am Nova A239, very happy to share stories